The book introduces a new function that you probably have not seen before, and it's called the greatest integer function. And it's represented with two sets of square brackets to the left and the right of whatever I want to do the greatest integer of. And to me, it's kind of confusing the way it's defined, but it's defined as the greatest integer less than or equal to whatever I put in the square brackets. For example, if I put 2.3 in, I want to know what the biggest integer is that is smaller than or equal to 2.3. Well, this greatest integer that is smaller than or equal to 2.3 would be 2. So the way I'm going to talk about this is, hey, it's the integer that's below whatever this number is. Okay? So other books define this greatest integer that's less than or equal to x. They give it a different name, and they call it the floor function. Okay? And with that different name, they put different symbols. It looks like the square brackets without the tops on them, and you can think of this as, hey, I want to find the value that's an integer that's underneath that number. So the way I'm going to use it in class is I'm going to call this the floor function, and anywhere you see the double brackets in the textbook, you can replace them with these. And if I want to know the floor of 2.3, it's the integer that's right below 2.3, which would be 2. Similarly, there is something called the ceiling function. And this is why I like these definitions, because they make intuitive sense for students. So the ceiling of x is the integer that's above, the nearest integer that's above x. So if I wanted to know what the ceiling of 2.3 is, I would get the integer that's above 2.3, so that would be 3. Where students have issues with the floor, ceiling, and the greatest integer functions are when they're dealing with negative numbers. So if I were to want to know what the floor of negative 1.1 is, well, it's the integer that is just below negative 1.1. Well, and that would be equal to negative 2. The way you can think about it is, here's your number line, here's negative 1, here's negative 2. Where is negative 1.1 on the number line? Well, it's right here. What is the integer that is at the floor of that little box? And it's negative 2. Same thing with the ceiling function. If I want the ceiling of negative 1.1, the ceiling of negative 1.1 is the integer that is just above negative 1.1, which would be negative 1. And again, if I think about it on a vertical number line, my negative 1.1 is right here. What's the next integer above the negative 1.1? It's negative 1. So when the book uses the greatest integer symbol, my recommendation is that you replace it with the floor symbol, and you use this analogy of using vertical number lines to figure out what the integer is for the greatest integer function. The graph of the greatest integer function is what they call a step graph, because it resembles a set of stair steps. So I'm going to show you what the graph of the function looks like, and you will be dealing with functions such as postal rates, tax tables, stuff like that, that will also give you step functions that you could rewrite in terms of the greatest integer, the ceiling, and or the floor functions. And I'm going to do a few values of this, and we're going to reason ourselves through the graph. Let's do the easy one. If I put, and I'm going to draw a vertical number line so we can ask ourselves the question. Several questions. So here's 0, 1, 2, 3, negative 1, negative 2. If I were to pick the number 0, where is the nearest integer at the number 0? Well, it is the number 0. So when I put a 0 in for x, I get a 0 in for y. If I put a 0.5 in for x, what's the floor for 0.5? Well, it's 0. If I put 0.9 in for x, the floor is 0. If If I put 0.99999 in for x, the floor is 0. And if I put a 1 in for x, the floor is 1. So I know if I put a 1 in for x, I get a 1. And everywhere in between here, I get 0, except at 1, I jump up to 1. Same thing here, between 1 and 2, every number is going to return a 1 until I get to 2, and my value would be 2. Over to 3, then my value would be 3. Over to 4, then my value would be 4. On the negative side, if I put a negative 0.5 in, what's my answer? It's negative 1. If I put a negative 0.1 in, my answer is negative 1. So everywhere between here and here for x, I am going to get a negative 1. And once I get to negative 1.1, it's going to drop down to negative 2. And this repeating pattern is what the graph of our greatest integer or our floor function looks like. Note that when x is 2, the y value is 2. When x is 1.5, the y value is 1. So this meets the definition of our greatest integer or our floor function.